welcome everyone. My name is Ihor Dvoretskyi. I'm a developer advocate at Cloud Native Computing Foundation. If you haven't heard about Cloud Native Computing Foundation, you could definitely hear about Linux Foundation. Cloud Native Computing Foundation is a part of the Linux Foundation, and I'll speak about that a bit later. Also, I'm a Google developer expert. Last Friday, I received this title officially, so I'm really excited about that. I've been working for Google-related efforts in the open source community and so on for years, and I'm really excited to be a speaker at this conference for the first time in a row. So that's really great. All right, so let's cover first of all what is the Cloud Native Computing Foundation is, what are the projects of the Cloud Native Computing Foundation, and why I'm specifically speaking here about Kubernetes, KNative, and all other stuff, including serverless. So, as I mentioned before, Cloud Native Computing Foundation is a part of the Linux Foundation. We've been founded in 2015. So, anybody here knows the history of Kubernetes? Just a brief remark. Just a few people, yeah. So, Kubernetes was originally the Google project. It was developed, it was open sourced by Google in 2014. Google internally has had and has the huge ecosystem of the container-related services, and all the services are managed by the internal system called Borg. Some pieces of Borg have been open sourced, and the new product has been released on the market by Google. It was an open source project called Kubernetes. The first days of Kubernetes were in 2014, but in the next year, in 2015, the first milestone of Kubernetes, Kubernetes 1.0, has appeared in the world, and Kubernetes was the huge effort for the industry. People have been really excited about having the technology that will allow them to deploy their containers. At that time, on the Docker containers, but we know that Docker is probably the most popular tool today to deploy containers. So Kubernetes was the best effort that days and the best effort today to deploy your containers on almost any scale. So the Linux Foundation, together with Google, who was the co-founder of Cloud Native Computing Foundation, they decided to establish the new foundation. The open source foundation for the projects were not only Kubernetes, can appear, but also projects like Prometheus. You could hear a talk yesterday about Prometheus by Tom. Hi, Tom. So multiple projects. We have multiple projects today at our ecosystem. We have more than 20 projects today that are more or less related to Kubernetes, and they are more or less independent. So we've decided not to establish the Kubernetes Foundation, but we've decided to establish the foundation for the cloud native world. So what was the story behind the Cloud Native Computing Foundation, behind CNCF, behind Kubernetes, and behind all their other technologies that you may use widely today in 2018? So at the beginning of the century, the typical way for you to use some kind of software was to deploy it on a bare metal server. And for those who've been using, for those people who are in this industry, have been in the industry 20 years ago, you couldn't ever heard about any kind of virtualization solutions. I'm not speaking about containers at all here. So non-virtualized hardware was the only way for you to use some kind of software on it. At the same time, companies like VMware, together with some other companies, they have started working, and they released in the market the virtualization software. So in the case of VMware was the pioneer in this market, and virtualization was the technology that allowed you to deploy anything, like any kind of operating system on the bare metal machine, but virtualized. So you could use the single machine for running different operating systems to virtualize your software, hardware, your computer sources. You could even run different kinds of operating systems, like you could run Windows and Linux and BSD systems on the same machine. So that was the great revolution for the industry. At the same time, using technologies, using the virtualization technologies still required you to own your own hardware. So if you are the small company, if you're the small startup, you still had to invest some money, some effort of your engineers to build this ecosystem, to build this environment on your own in your own data center. AWS came on the market first with the infrastructure as a service solution, where you should not own the hardware to use it. You should simply pay for the third-party company, in this case AWS, to use their hardware on demand. So if you're a small startup, and if you are selling some goods before Christmas, for example, and like the typical grade of selling your goods during the year is like not so high, but right before Christmas you may have the huge upscale of your customers, and if you'd been using the hardware, your own hardware, you had to invest some money and some efforts into it. And what will you do after the Christmas peak will decrease again? So you will have tons of unutilized hardware. So using infrastructure as a service on the public clouds was the great solution for the companies who did not want to invest to hardware, but instead they simply would like to invest their time and money into infrastructure itself. At the same time, using ES systems are still required from you. If you are using the systems, you still had to know the basic principles of using the operating system. So you still had to know how to install Linux, for example, or install some applications on top of it. So you had to still use the whole stack of applications just to run your personal application that you're going to develop there. So companies like Heroku, they proposed another way of doing this stuff. So if you're using PaaS, platform as a service systems, you as a developer, you should simply care about your code. Everything else will be handled on the side of the provider. The next milestone on this timeline is the open source SaaS. So we are coming back to the AWS story and ES story itself. And so again, the major purpose of Amazon and AWS was that one of the major purposes of it, that you could easily spin up any kind of compute or networking or storage resources via API. So it was really the software-defined infrastructure managed by the third party. For some companies, especially some financial institutions or telecoms, it was not the best way to operate because they required to utilize their own data centers to store the personal data of the customers, to decrease latency in the case of networking stack and so on. So OpenStack is the open source software solution for building infrastructure as a service relevant on the market, and it was around 8 years ago. The similar approach has happened with the PaaS systems. So if you are a developer, if you have a team of developers who'd like to simply run some code somewhere, but you'd like to utilize the infrastructure that is managed by you, it can be bare metal or it can be the public cloud. You could use the technologies. For example, Cloud Foundry. So today, Cloud Foundry is yet another foundation under the Linux Foundation governance. They have tons of companies and tons of offerings in the PaaS space. And if you'd like to use PaaS today, Cloud Foundry can be one of the best options for you. But coming back to technologies, neither PaaS or ES have solved the main problem, the main goal of developers, the main goal of system administrators, the main goal of DevOps engineers. How can I ship this code? How can I write some code on my local machine, on my local laptop, I don't know, even on my Raspberry Pi, and run it in the same way on my, for example, QA environment in my small data center under my working table, or in my public cloud based on Google Cloud. So Docker was a solution to solve this problem. And another big issue with using the different technologies, for example, using the virtualization technologies, that virtualization itself brings a huge overhead to your resources. So if you'll compare the performance of your machine that is deployed, of your like typical Ubuntu machine that is deployed on the regular bare metal server, and you'll compare that with the performance with the same specs on the virtualized software, you'll see the huge decrease in performance, like 15 or 20% of overhead. And that was really not acceptable because you are paying extra 50-20% of your time, money, CPU resources, hardware resources, and so on. So using yet another technology that will allow you to utilize almost all the resources of your machine was also required. Docker was a pioneer on the market of the containers. I have to make a remark that Docker was not the first company on this market, and Docker as a solution, as a technology solution, again, it was not the first solution in the space. So some of you could have heard about LXC containers, OpenVZ containers, but the biggest difference between LXC, OpenVZ, and Docker is that OpenVZ and Docker containers and LXC containers were primarily designed to replace virtual machines. They've been designed for system administrators and DevOps guys, not for the developers and not for people who would like to simply consume code and run code somewhere. Right, so Docker won in the market. Today, almost everybody who is using containers using Docker. But the biggest issue with Docker is that you cannot easily scale your resources with Docker. So it's terribly easy to run Docker on your local machine, on your local laptop. But what if you have the huge data center, or if you're using the huge tenant, for example, from Google Cloud, Amazon, or Azure, and you are using like 5,000 machines? What you'll do with Docker? How can you manage all the stuff that's happening there? So there was a high demand on the market for the technology that will allow you to manage all that great forest of containers. There have been some alternative solutions like Docker Swarm, the in-house solution from Docker. There have been also Mesos by Mesosphere, another solution for managing containers. But Kubernetes was that solution that again, it won the market, and I'll show you that a bit later. So that was the history. And like the final point on this slide is 2015. Let's imagine what we'll have next. Any ideas? No? Okay, here's serverless. Not sure. We have this. No, it doesn't work. Come on. What's happening with my clicker? All right. So we have yes, this. Come on. Yes, we have this. So we have the huge amount of technologies. This is the CNCF landscape. Actually, you had to have the printed version of the CNCF landscape in your goodie bags that you could receive yesterday during the registration. So you should not break your eyes, especially from the rare rows, to try to read it. At the same time, I'm really excited about this venue because, like in a different venues, it was much more difficult to show this slide for people. So on this slide, we have all the technologies that exist today in the cloud-native world. Not only CNCF technologies, not only cloud-related technologies related to CNCF, but everything that is here in the cloud-native world. So this slide is the way for you. How can you find exactly the technology that you are looking for? If you are looking for example, for the networking solutions or for the storage solutions, if you'd like to build your environment using the modern technologies. At the same time, as someone mentioned in the audience, we have, or we don't have, it doesn't work again. All right, we have serverless. We have a landscape in a landscape. You'll see it right there. You cannot see it actually. Yes, we can see it. So the serverless landscape is a bit smaller, but still not so easily readable. So the biggest difference between serverless landscape and the container-related landscape is that if you're looking for a single technology that will allow you to orchestrate your containers, there's a clear winner today. It's Kubernetes. But if you're looking for the technology that will allow you to use something serverless, you have tons of options. I'll not stop here, so I would suggest you just to check the interactive version of the serverless landscape. It's available on s.cncf.io. So if you are going to build some kind of serverless infrastructure, serverless architectures, you have tons of options, and all of them are listed here. All right. So let's move on to Kubernetes. As I mentioned before, Kubernetes is a clear winner on the market of the container orchestration systems. Kubernetes is a clear winner in your way. How can you consume containers in the environments of any scale? So why people are selecting Kubernetes? Why companies are investing their time and money into Kubernetes? Why companies are building their products on top of Kubernetes? And why end users are using Kubernetes? So first of all, Kubernetes is absolutely open sourced. As I mentioned before, Google released Kubernetes as an open source version of the internal software. Another big benefit of Kubernetes as an open source solution that it doesn't belong to Google or any other company. Like Kubernetes as a project and Kubernetes as a trademark belongs to the independent open source foundation. So any company in the world can contribute there. And for example, we have Google, which is the top contributor to Kubernetes. At the same time, we have different companies like Red Hat, Microsoft, Amazon, tons of them that are contributing their time and code into Kubernetes. Also, Kubernetes is written on Go. Any Go developers here? You know how Go is pretty easy to consume and to write something on it. So if you haven't tried writing something for Kubernetes, it will be terribly easy for you. Should be. So another big benefit of Kubernetes is that it's operating system and host neutral. So you can run Kubernetes on your laptop with Minikube. You can run Kubernetes on your own bare metal machines, for example, with tools like kubeadm. You can run Kubernetes as an offered service, for example, from Google with GKE or with Amazon, with Azure, with tons of companies that are offering their commercial services, commercial products based on Kubernetes. Another huge benefit of using Kubernetes is that it's terribly secure. So if you are running some applications on Kubernetes and if you are using Kubernetes for running them, they will be totally isolated from your environment. So on one tier, you are managing a Kubernetes cluster. On different tier, you are managing your underlying infrastructure, or not managing, just offering that to companies like Google. Kubernetes is extremely flexible and configurable and extensible. So Kubernetes is just the base, it's just the foundation for building something different and something on top of it. So Kubernetes cannot solve all of your issues, all of your questions, but you can easily extend it with some extra functionality. And Kubernetes is extremely scalable. So as I mentioned before, the biggest downside of using pure Docker was that it was extremely difficult to scale it for the huge environment and easily manage that from the single control plane. So Kubernetes allows you to do that. Today you can handle up to 5,000 node clusters with up to 150 pods on each. So Kubernetes is the right solution for running extremely big environments based on the container ecosystem, based on the container environments. And probably heard about companies like Spotify or Bloomberg. They're running Kubernetes for their services. If you're using Spotify, you're using Kubernetes. All right, just a few graphs again about how Kubernetes dominates the world. So today most of the environments that are containerized, they are using Kubernetes. And on this slide, you may notice how Kubernetes is dominating the world of the containerized technologies, and not even on the first line there, but also on the next few lines with GKE, for example, or OpenShift and or Chorus Tectonic. That was the last year offering by Chorus. This survey was conducted last year, so some kind of data can be a bit outdated, but it changed a lot this year, even in a better side. And again, if you are using some kind of containerized technologies in your public cloud, you are using Kubernetes. And most of people are using Kubernetes. And again, Kubernetes is not the final solution that will satisfy all your needs. But first of all, Kubernetes is a platform that will allow you to build almost anything on top of it. And the cloud native stack that is offered by the Cloud Native Computing Foundation, and that was shown on a landscape slide, tons of the offerings that have been shown there, they are based on Kubernetes, or you can use them together with Kubernetes. Including KNative, the one that we'll speak about today, KNative and Istio. So moving forward to Istio, don't have so much time right now, unfortunately, but I'll cover Istio with just the few phrases. So Istio, again, it's the open source solution that was also developed by Google. It was also open sourced by Google. It's not a part of CNCF today, but it's an organic part of our ecosystem. And Istio is exactly that solution that will allow you to use Kubernetes for building microservices. Because Kubernetes itself does not offer you some kind of benefits that you have with Istio. Including some extra security while routing your requests. You can use Istio for running different versions of your application on the same environment and so on. So just check this slide briefly. Istio has tons of benefits, and if you are looking for the great solution for managing your microservices on the Kubernetes cluster, Istio is exactly that solution. So as I mentioned before, the biggest downside of using technologies like Kubernetes or anything similar, that they are mostly adopted not for developers themselves, but for more technical proficient people. The new open source project released on the market a few months ago, it's called KNative. KNative is the joint effort by companies like Google, Pivotal, Red Hat, IBM, and some others. How can you use and consume your applications? How can you simply run some code just everywhere, just with some basic partners of deploying it somewhere? And you don't care what's under the hood. Under the hood is Kubernetes, because Kubernetes, again, is a great platform for doing that. But if you are just a code developer, you don't care about it. So again, why KNative? Why people are using KNative, and why people are selecting KNative? Again, it's absolutely open sourced. It's available on GitHub. Again, it's not the CNCF projects right now, but it's a great and organic part of our ecosystem. And it's available on GitHub. Here is the link to GitHub. KNative, again, KNative is native to Kubernetes. You can run KNative on any platform, on any Kubernetes-compatible platform, on any Kubernetes-conformant platform. So, for example, the previous presentation in this hall was about the different serverless solution that is absolutely vendored. If you'd like to use the serverless platform, for example, on Google Cloud, that is the vendored solution, and in your own data center with Kubernetes, you can use KNative for that. Because the different solutions, the similar solutions that are offered by different companies that are commercial solutions, they cannot allow you to use the same code base, the same API, the same ways of interacting with it, on your own machines, on your own bare metal, together with the public cloud. So this is one of the greatest benefits of using KNative, that you can run this serverless platform on your own Kubernetes cluster. You can run it on for example, on Google Cloud, on Pivotal offering, and so on. And KNative also offers the huge amount of benefits for the developers. So you can easily develop and deploy the applications and functions. You can allow the zero downtime upgrades for your application. So again, the biggest benefit of using KNative is that you should not interact with the underlying infrastructure. You simply write code, you simply push it to your KNative cluster, and everything else will be handled by KNative. There are a few concepts, basic concepts of KNative. One of them is KNative build. It's the pluggable model for building the components from source. So with KNative, you can define your Docker file, for example. You can define some Golang or Node.js or Python application. Just run a few commands and it will be deployed on KNative. So terribly easy. Again, it's serverless. You didn't see what's under the hood. The build system is based on the Google container build system, but again, it's total open source, so you are not locked into any kind of Google infrastructure. And if you are a developer, you can also define any kind of source for your application. It can be the GitHub repo, it can be the container registry, and so on. Another big concept, major concept of KNative is serving. The serving concept automates the flow from containers to run some function. So if you are building something, you have to run that, and the serving concept of KNative will allow you to do it. And it's based on the request, so it's the request-driven runtime. And if you'd like to route some traffic to your microservices, it will consume Istio, which is again it's a part of KNative. Here again, you can probably try this. All right, and the final major concept is events. So Eventing provides the building blocks for consuming and producing events with KNative, and it allows also the developers to be agnostic for the messaging platforms that they are using. And this slide actually highlights how the typical KNative workflow can look like, and what are the major components of KNative. So on the bottom line, you can see the platform providers. For example, it can be the Google Cloud with the Kubernetes offering. Here we have Kubernetes on top of the underlying platform, and on top of Kubernetes, you install and use KNative. KNative is that component of this picture, which interacts with the developers that are consuming it, and it's also open source. Again, it's available on GitHub, and it will allow you to consume and to publish some kind of open source solutions that will interact with KNative. And the final one is Istio. So Istio is the service mesh, is your gate for interacting with all these platforms. So Istio is exactly that component that allows you to work with KNative and Istio. And the major point is that the code is what the developers should focus on. So if you're using the serverless platforms, if you're using KNative or any other kind of serverless infrastructure, you should not care about what is under the hood, what kind of networking or what kind of storage solution is being used. You simply run some code, you simply consume it. All right. Now we have a few minutes for demo. It's actually available on GitHub. It's terribly simple, but I'm going to run it right now. I'm not sure how much time do we have. All right. So the first part of the demo, I'm not going to deploy KNative right now. It's already deployed, but we're using some basic script where you can install, you can run KNative on your GKE cluster. So with this script, you deploy the most typical GKE cluster with 3 nodes with the machine type and 4 standard and blah blah. The next part, you have to install Istio. So you are deploying the Kubernetes cluster. Again, you can use any kind of Kubernetes cluster. There are also available tutorials for running that on Minikube, for example, on your local machine. Here we're using Google Cloud. So you can use Istio for running. Here you have to use Istio to deploy KNative later, and you actually deploying KNative here. So as you can see, if you're familiar with the Kubernetes CLIs and interfaces, so kubectl is the command line for Kubernetes, and every component, including Istio and Kubernetes, is being deployed by Kubernetes. All right. So now, we have the sample hello world application. So this is the basic application that just handles the requests, just the basic web application that handles the requests. It's the basic web server that is operating on the 8080 port, and after your request, it returns to you your target, which is world right now in the sample. So we are going to return something like hello world. And the next part, we are using the Docker file. Again, it's the pretty basic Docker file that uses this hello world go file. You simply have to run and build it, and we have the service YAML file, which actually uses KNative for using on Kubernetes. So it's a Kubernetes service, and it's using the KNative API. So KNative is yet another sample how Kubernetes can be extremely extensible. So with CRDs, which are the customer source definitions, you can extend Kubernetes in almost any way, and customer source definitions is the way how can you extend the APIs. So there are the typical APIs, the standard APIs of Kubernetes, and you can simply add a few new with CRDs. So this is the great sample of how it can be achieved. And so we have the defined service YAML file with the Hello World Go application, and we just have to build it and push it to register. So right here we're using the GCR registry. We can also use Docker Hub and like anything similar. Just for this case, we're using the GCRIO, and we have to simply apply it. So right now I have the pre-deployed cluster. Hope you can see my screen. Make it a bit bigger. Yes, so right here we are using the kubectl, the generic CLI command for Kubernetes. We retrieved the basic information about our KNative deployment with ingress and in the Istio system namespace. And we are doing that for finding the IP address of our service. And if, I'm going to export the system variable to receive our IP address here, and we'll find the URL as well. Come on. Perfect. And we'll export that as well. All right, and the final one is that we have to receive the some welcome message from our application. We have hello Go sample because we have the value target in our service YAML file for Go sample here. All right, just a few links. So if you have any questions, we probably may have some time. I don't know if we have some time for questions right now.
Thank you, Ihor.
Perfect. Thank you.